How to stop CNN overfitting with dropout and data augmentation. Imagine training a computer to recognize images, but it gets so good at memorizing your training pictures that it struggles with new ones. That's called overfitting, and it's a common challenge in convolutional neural networks. Overfitting happens when the model learns noise or tiny details that don't matter outside the training set. It's like studying only one textbook and failing to answer questions on different tests. To make CNNs better at handling new data, we need to teach them to focus on the right features, not just memorize. Two powerful tools for this are Dropout and data augmentation. Dropout works by randomly turning off some neurons during training, so the network can't rely on any single part. This forces the model to spread out what it learns across many neurons, making it more flexible. Usually, dropout is added after convolutional layers or fully connected layers, with a dropout rate between 0.2 and 0.5. The higher the rate, the more neurons are ignored temporarily. Data augmentation, on the other hand, increases the variety of training data by creating new images through transformations. These transformations include rotating images by small angles, flipping them horizontally or vertically, zooming in or out, shifting the image slightly, or changing brightness and contrast. For example, if you have a dataset of 1,000 images, applying these changes can multiply your dataset by several times, giving the model more examples to learn from. This helps the CNN recognize objects regardless of their position, size, or lighting, making it more robust. Combining dropout and data augmentation is especially useful when your dataset is small. Dropout prevents the model from relying too heavily on specific neurons, while data augmentation ensures the model sees many different versions of the same object. This helps your CNN generalize better to new, unseen images. In real-world applications like image classification or AI tools such as ChatGPT, DALL-E, or Midjourney, preventing overfitting means your model will perform well on new inputs, not just memorize training data. To put it into practice, start by adding dropout layers after your convolutional or dense layers, choosing a dropout rate that suits your model, usually around 0.3 or 0.4. Then, during training, apply data augmentation by randomly transforming your images with a library like TensorFlow or PyTorch. Keep an eye on your validation accuracy. If it stops improving or starts decreasing, it's a sign of overfitting. Adjust your dropout rate or augmentation parameters accordingly. By using these techniques together, your CNN will become more resilient, better at handling new data, and more reliable for real-world tasks.